So in this class we'll see how inheritance works with abstract classes. In the previous class I mentioned that an abstract class is always created by using the keyword abstract. Okay, so in an abstract class you need at least one abstract method. So here in this mammal class I have a method called walk, which basically which lets the mammal walk from point A to point B, and it's an abstract method, so it doesn't have any implementation here. And this mammal class is the base class or the superclass, and we have a tiger class which is a subclass. And this tiger class is a concrete class because it doesn't have the keyword abstract in front of it. And this tiger class actually provides an implementation for the walk method. So the walk method is you're giving a body inside the derived class or the subclass. So let's see what happens if we do not provide this implementation. So let's comment out these lines, and you will see that there is a compilation error which says the type tiger must implement the inherited abstract method mammal.walk, because here we are saying that tiger is not an abstract class. It is that means it's only the only other option is it's a concrete class. So for a concrete class it must implement all the methods that it inherits from the base classes. Actually it needs to implement all the methods that it inherits from its parent classes. Okay, in this particular example we have just one parent class, but if mammal inherits from another class and there are some abstract methods, public abstract methods in those classes, then tiger needs to implement those methods as well. So here our options are either you make this class also abstract, the tiger class also becomes abstract, and then you cannot instantiate a tiger anymore, so you need to comment out these lines. So now tiger class also becomes an abstract class, so you cannot instantiate even a tiger. If you try to instantiate a tiger, it's going to complain that tiger is an abstract class and you cannot instantiate it. So let's make tiger a concrete class, and when we make tiger a concrete class you'll get an error which says it should implement the walk method. So let's uncomment this method out, and now the tiger class has become a concrete class because you have implemented all the methods, all the abstract methods from that the tiger class has inherited. It has inherited from the mammal class, which is an abstract class which has one abstract method, so it needs to provide an implementation for the walk method, which is an abstract method in the mammal class. So let's make one more change now. Now we have a concrete method in the abstract class. In an abstract class it is not a requirement that it should not have concrete methods. Yes, it can have one or more concrete methods, but the basic requirement is it should have at least one abstract method. It can have one or more concrete methods, but it should have one abstract method. That's the key. Okay, so let's make the run also an abstract method. And how do you make something abstract? You use the keyword abstract in front of it, and then you remove the body of the method and make it abstract. So because you have made this run method abstract, you have to remove its body and put a semicolon which just provides the method declaration. So if you have two methods declared here, the walk method and the run method, and they are both abstract. So in the tiger class it's a concrete class. It already implemented the walk method, but now since the run method has become abstract, it needs to implement that as well. So what are our options here? There are two options. Either we add the unimplemented methods, that is provide an implementation for the unimplemented methods. In this case the only unimplemented method is run, so we have to provide an implementation for the run. Or your other option is to make tiger class also abstract. Okay, so you can make the tiger class abstract and the compilation errors go away, but you cannot instantiate a tiger. So you still need to comment out these two lines. Okay, so our other option is to make this tiger class a concrete class, but in that case we need to provide an implementation for the run method, because it's a tiger is now a concrete class, so it should provide implementation for all the methods, for all the abstract methods. So now we have provided an implementation for the run method. So now the tiger class is a concrete class, and now you can instantiate the tiger class. Now the tiger can walk and the tiger can run as well. See, tiger is okay. Tiger is, oh, I need to make this run. Now if you see, it will say tiger is walking from Dallas to Irving, tiger is running from Dallas to Irving. So this is how you use inheritance with abstract classes. So you can make the derived classes abstract by not implementing all the abstract methods that it inherits from its parent classes, or you can make the derived class a concrete class by providing an implementation for all the public methods that it inherits from its parent base classes. Okay.